Hey Sydney, or whoever else this can be useful for. I'm going to show you how you can analyze data for two discrete variables, so meaning not continuous. So in this particular example, this would be for, say you're doing an experiment where you want to see if texting parents the night before can increases the likelihood that a student will complete their homework. And this is the example that Sydney, I think this is what Sydney's doing her thing for her project, so I'm going to show you how she could analyze that data. So here's some sample data for that in Google Sheets. So here's the students, and Sydney was asking if you can what it's called dummy coding, what she was suggesting, putting zeros or ones to represent texted or not texted and homework completed or not completed. But you can do zeros or ones, but you can also just do no or yes. Jasp can analyze it either way. So here we have the first 9 students. The parents were not texted the night before, and here it says whether those students completed their homework or not. And then these next 9 students, I'm supposing I have a class of 18. They were texted, their parents were texted, and here in this column it's showing whether they completed their homework or not. Okay, so first thing we want to do is turn this into a CSV file. So we go to File, Download, and go down to comma-separated values, .csv. Okay, now from here we can go ahead and open Jasp to analyze it. Alright, let's see. Okay, so let's go over here, open our file, go to computer, it's in my downloads, so I'll click here. Okay, so here's our data. So the way we want to do this is we want to use frequencies and go to the contingency tables. So this is going to do something called a chi-square test. So here, let's do it like this. I'm going to put the parents texted in the columns and homework completed in the rows. Okay, so, and also I'm going to go down to cells and turn on percentages by column. Okay, so what we have here is just a description of the data, so in a frequency table essentially. So let's look here at first, parents texted no. So of the parents of the students whose parents were not texted, 5 of them did not complete the homework, 4 of them did complete the homework, and we have the percentages here within the column. So this is saying that 55% of the students whose parents were not texted completed the whole homework, about 56, and here that about 44% of students whose parents were not texted did complete the homework. Okay, and you can read this the other way around. This is for ones whose parents were texted. Okay, so what do we do here? Well, first of all, it looks like there's evidence that texting the parents did help. I just made up the data that I used using random number generator, and it's showing that it's clear that the parents who's texted, the students whose parents were texted, they had a much higher likelihood of completing their homework, 67% versus only 44% about for those whose parents were not texted. Okay, but how do we know this wasn't a fluke? How do we know this wasn't just, it's not very many, we didn't actually work with very many students, so how do we know it wasn't just on accident that the ones whose parents were texted did better? Well, that's what we look down here for. This is a chi-square test that it does. And essentially all we want to look at here is this p-value. This is a p-value that it just tells you whether the results are statistically significant. And the convention, of course, is that the p-value needs to be less than 0.05. Let me write that really quick. So we want p to be less than 0.05. If it is, we say it's statistically significant. This p-value, 0.343, is not less than that. So we could not say that the result is statistically significant. Specifically, this is saying that there's about a 34.3% chance that we would get exactly these results if there really isn't any effect of texting the parents. So that's a small chance, but it's not low enough to say that the results are statistically significant. Hope that helps.